Assalamualaikum. My name is Muhammad AMIRUL bin JAMALUDIN and my supervisor is SAIFUL BAHARI bin SHAARI. Today I'm going to present about design of a compact hybrid generator based on magnetic mechanism. For introduction, this project aims to generate electric power from green energy or renewable energy by using a magnetic mechanism as the element source and producing a high output current from a low input current. This hybrid generator may overcome the limitation of traditional renewable energy technologies due to weather and space constraint. The existing prototype of hybrid generator may be improved to boost its capabilities and efficiency in producing more power. Okay, for literature review, first I'm going to talk about renewable energy. Renewable energy or alternative energy sources or energy sources that can be replenished, provide energy again and are infinite. They can enhance living conditions and provide most energy requirement without running out. Because of their low GHG emission, they do not cause as many health issues as fossil fuel. But they have a high initial cost and storage system cost, and very dependable on weather condition. For Lenz's law states that the current induced in a current due to a change in magnetic field is directed to oppose the change in flux and to exert a mechanical force which opposes the motion. For example, when a ball magnet north pole approach the coil here, the induced current flow in such a way that the side of the coil nearest the pole of the ball magnet itself become a north pole to oppose the approaching ball magnet. So the coil here also will become the north pole to oppose the movement of the ball magnet that want to go in the coil, and it will oppose the direction and the magnet will out. Upon withdrawing the ball magnet from the coil, the induced current reverses itself and the near side of the coil becomes south pole to produce an attracting force of the receiving ball magnet. So when out, it become S, is become N, so it will attract to oppose the direction of the ball magnet that want to go out. Next, for Faraday law. Faraday law is the basic law of electromagnetism, which helps us to predict how a magnetic field would interact with an electric circuit to produce an electromagnetic force. This phenomenon is known as electromagnetic induction. So, moving a permanent magnet, for example, moving a permanent magnet into and out of a coil of wire also induced a current in the wire while the magnet was in motion. So, if look at this diagram, the stationary magnet result in no current in the galvanometer, but a rightward moving magnet result in a current here in deflect in the galvanometer. A faster moving magnet will also result in increased current. It deflect more in the galvanometer. A leftward moving magnet result in an opposite current, so it deflect in the opposite direction. Lastly, for solenoid, a solenoid coil is a typical electrical component that generates an electromagnetic field by tightly wrapping a wire around a core, which is commonly constructed of metal. The electromagnetic field formed when an electrical current is fed through the coil provides energy for linear motion. In comparison to a permanent magnet, an electromagnet may alter the magnetic field by varying the value of its electric current. The number of turns of the coil also influences the intensity of the magnetic field. The magnetic field intensity increases as the number of turns increases. Next, for problem statement, the main issue with the existing renewable energy are high initial costs and rely on weather. Wind, as for example, wind generated electricity is affected by the turbine design, density, and the wind speed. For solar PV generation, on the other hand, is dependent on the strength of the light at that location and impacted by clouds. But for our hybrid generator, it is a system that can solve this concern since it has a lower starting cost and generate power via magnetic induction, which is not affected by the weather. But the disadvantage of this is that existing hybrid generator technology with a magnetic mechanism takes up too much space and difficult to carry. Not only that, it also the output current produced also is insufficient for use in advanced electrical equipment. So for our objective, we plan to study the most efficient mechanism that convert linear motion into resonance motion and focus on generating the highest torque output with a compact design. We also We also try to implement the innovative mechanism like one-way bearing, rack and pinion system, quick return system, and crankshaft system. For scope and limitation of the project, the magnitude of the product talk is being focused on this project in order to produce a high output. The mechanism that transforms a linear motion into a rotating motion, having to function in tiny space, guarantee that the project aims of generating a compact design is met. To ensure better production, we must also identify techniques to improve the torque produced by rotating motion. Finally, there are three hybrid generator design concepts developed using a CATIA software, and each of these designs will be analyzed by calculating the force and the torque produced. For methodology, uh, it will describe all the procedure and method used in a hybrid generator design. So finally, as the result of all these pieces, a final design will be computed. For the methodology, we start with study the mechanism to generate current. Then we identify the problem and improvement that can be made. We develop some CAD model for compact and higher output magnetic generator using CATIA software. Then we analyze the best design for compact and highest output of magnet generator by calculating the torque produced. Then we will discuss the result. So for mechanism of hybrid generator, firstly the current will supplied to the solenoid from battery or power adapter. Then the current flow to the solenoid to create an electromagnetic force. The electromagnetic field force from the solenoid move the cylinder magnet in a linear motion by adjusting the flux of the solenoid. A relay is used then to shift the pole of the solenoid, causing the shaft of the solenoid to reciprocate. The reciprocating motion generates mechanical energy, which is converted into rotating motion by a conversion system like crankshaft, quick return mechanism, and others. The shaft rotational motion will move the permanent magnet generator, converting mechanical energy into electrical energy. Next, for our design CAD design model, this is our first design concept. The specification of the design is it uses a simple system integration and utilize a crankshaft here as the device to change the linear motion into rotational motion. Next, it uses a two-stage transmission system to boost the torque output here in the blue gearbox in the CAD model. Next, for the second design concept, this concept is more complex compared to the first design. It uses a quick return mechanism to convert from the linear motion into the circular motion. It uses a two-step transmission system to boost the production of torque here in the gearbox. Lastly, for the third design concept, this concept uses a unique system integration that employs one-way bearing application. The one-way bearing will be placed inside this cover. This design uses a rack and pinion mechanism to convert the linear motion into the rotational motion. This design also is very portable and light in weight. It uses a direct gear system to boost the torque output. This is gear. So lastly, for expected result, this is the free body diagram of our fourth design concept. This is the second FBD of our design and the third FBD of the third design. So for calculation for force due to the solenoid, the Fs is equal to Ni, and we get 30 Newton for the force that due to the solenoid. This is the same for all the three design because we use the same solenoid design for all the three products. Next, for the first design concept, to calculate the torque, we use T equal to F multiplied by D, and we get 0.9 Newton meter. For second design concept, to calculate the torque, we use T equal to RF sin theta, and we get 0.893 Newton meter. For the third design concept, we use the FR mg mu plus MAFS, where Fs is the force by solenoid, Fr is the force on the rack. So for on the rack, we will get 80.098 Newton. Then we want to we want to count the radius of the pinion. We will use dp diameter of the pinion divided by 2 2000, and we will get the radius of the pinion equal to 0.012 meter. So torque of the pinion, we use TP equal to FR multiplied by radius of the pinion, and we will get 0.96 Newton meter. So for discussion, the third design concept was chosen as the final design because it produced the maximum output torque of 0.96 Nm when compared to the first and second design concept. The third design also likewise highly compact and simple to carry, which met the project aims of developing a compact design capable of producing high output torque. Finally, we employ two one-way bearings to transmit this movement to an axis with the same and constant speed. This system distinguished the design as one of a car mechanism that employ a one-way bearing as well as a rack and pinion system to convert linear motion into a rotational motion. That's all from me. Thank you.